Good morning and welcome to our discussion this moment. Today we want to look at the probability distribution of fake coins. We have just had a class that bordered on the probability distribution of fake coins when three coins are tossed up together. And in that class, we made a reference to the fact that when the number of coins increases or the number of trial of increases, that obtaining the probability distribution, the range space, and then the sample space can become very challenging. And then we gave a formula that can help us to quickly navigate our way out of the hook. And that is what we want to show this morning. So the question is, when four fake coins are tossed up together, that we should one obtain the range space, R substitute what X, and then we should obtain what we call the probability distribution. Probability distribution. Probability distribution. So permit me to divide this board, sorry. We are talking about four fake coins. And then we want to now determine the range space, where this X is counting the number of what heads that will come out each time that we try it. So it is possible that when you bring four coins and you toss all of them together, you can be lucky enough to get head in all of them. And then when that random variable X comes to count the number of what heads, it is going to count it now to be 4. So in that case, when you want to talk about the range space, your R substitutes X. It is going to be a set that contains 4, comma. That is where you tossed 4 of them and you were lucky enough, and then you had all of them to be 4 heads. But you do know again that it is possible that when you toss 4 of them, you may not necessarily have 4 heads in all of them. You can be lucky to have 3, and then the other one becomes what? Tail. So in that case, you have what? 3 here, comma. It's equally possible that you now toss 4 of them and you happen to have 2 heads. The other 2 becomes what? Tail, and in that case, you have 2. It is possible you toss and only 1 will be head. The other 3 will be tail, so you have 1. And it is possible that you toss the 4 and you never had a head at all. All of them becomes what? Tail. In that case, you have 0 head. So here becomes what? 0. You close up what? The brackets. And this thing becomes what we call the range space. In this range space, what this 4 stands for is occasion where you had 4 heads occurring in a trial. This 3 is an occasion where you have only 3 heads occurring. This is what? 2 means places where you have only 2 heads occurring. 1 here means places where you have only 1 head occurring. 0 here means a place or places where you have only tails occurring, no head at all. And this range space can equally be written in this case. It can be written as what? R subscript X is given as 0, 1, 2, 3, and 4. This and this are the same thing because changing the position of the elements in a set does not redefine the set. So this and this are the same thing in set algebra. So we are now going to use this idea now to determine our probability distribution. We are lucky we have been able to address the issue of a sample space. It is now for us now to get the probability distribution. For us to get the probability distribution, we are going to use this approach. We are going to use N combination R. Our N is going to stand for the number of coins that we have or number of trials. And our R is going to represent 0, 1, 2, 3, 4. So when R becomes 0, we are saying the number of places where we did not have head at all. It is only tails that we have there. So for me to determine that, I'm going to say my n is 4 coins that we are dealing with. This is 4 combination what? 0. Combination 0 here is where we did not have head at all. Then we are going to have it now to be 4 factorial all over. Here becomes what? 0 factorial into 4 minus what? 0 factorial. Because this is how to express 4 combination 0 this way. So that this thing becomes what? 4 factorial all over. Here is what? 0 factorial. 4 minus 0 is still 4. So we still have multiply by 4 factorial. Since we have 4 factorial up and 5 factorial down, this will cancel this, and then the answer will give you what? 1. So the number of places where we have only tails occurring is 1. Then we come to this 1. We want to go and determine the number of places where we have only one head occurring. And then we come and we now say 4 combination 1. This thing becomes what? 4 factorial all over. Here is 1 factorial into 4 minus what? 1 all factorial. This thing becomes what? 4 factorial all over. Here is my 1 factorial multiplied by 4 minus 1 will give me 3 factorial. So this will become 3 factorial. In trying to express this is 4 times 3 factorial all over 1 factorial times 3 factorial. This 3 factorial will cancel 3 factorial and we are left with 4. 1 factorial is still 1. 4 divided by 1 will give you this is 4. So the number of places where we have only one head is 4 of them. So I want to go and determine the number of places where we have 2 heads. So I will now say this is 4 combination 2. This thing becomes 4 factorial all over. Here is 2 factorial into 4 minus 2 all factorial. This thing becomes 4 factorial all over. Here is my 2 factorial multiplied by 4 minus 2 will equally give me 2 factorial. This becomes, here is my 4 factorial, or this is 4 times 3 times 2 times 1 all over. 2 factorial means 2 times 1 times. 2 factorial equally means 2 times 1. So that here, my 2 can cancel this 2 here. These 2 can cancel 1 and cancel this 4 to give me 2. 2 times 3 will give me what? 6. So the number of places where I have only 2 heads is 6. For me to get number of the places where I have only 3 heads, I am going to use 4 combination 3. This thing becomes 4 factorial all over. Here becomes what? 3 factorial into 4 minus 3 all factorial. This thing becomes what? 4 factorial all over. Here will now be 3 factorial multiplied by 4 minus 3 is 1 factorial. So this thing becomes 4 times 3 factorial all over. Here is my 3 factorial multiplied by 1 factorial. This 3 factorial will cancel 3 factorial. 1 factorial is 1. 4 divided by 1 will give me 4. So the number of places where I have 3 heads is 4. The last but not the least is where I have now 4 heads, which becomes what? 4 combination what? 4. And you bear the witness that 4 combination 4 is 1. You can confirm that. 4 combination 4 will give you 1. Now, with this thing means a place where you have 0 head, 1, where you have 1 head, 4, where you have 2 heads, 6, where you have 3 heads, 4, and where you have 4 heads, but 1. With this, you can prepare your probability distribution. You draw a table like this. You draw a table like this. Okay? Then you have this. Here is your x. Here is your p of x. You close it up. Then you divide this way. Here is your 0, so you put 0. Here is your 1, you put 1. Here is your 2, you put 2. Here is your 3, you put 3. Here is your 4, you put 4. Then you want to go and determine the probability of that of 0. For you to determine the probability of that of 0, first of all, count all the possibilities you can have. This is 1 plus 4 is 5, plus 6 is 11, plus 4 is what, 15, plus 1 is what, 16. So the total possibility you can have is 16. And this 16 can equally be obtained by asking yourself, this coins has how many faces? You say it has 2 faces. How many coins are involved or how many trials are involved? 4. So you can equally use this formula 2 raised to power n, where n is talking about the number of what coins or the number of trials, and it is 4. And 2 raised to power 4 here is what is 16. Then with this 16 in our mind, we now return back here. We ask ourselves, how many places do we have 0 here? Only 1 places. So the probability is going to be 1 over 16. So here becomes 1 all over 16. We come here. 1 here means the number of places where we have only 1 head, and there are 4. So it becomes what? 4 all over 16. 2 here means the number of places where we have only 2 heads, which is here. It is 6. So we have what? 6 all over 16. 3 here means the number of places where we have only 3 heads, which is 4. So we have 4 all over what? 16. And then 4 here means the number of places where we have only 4 heads, which is 1. We have 1 all over what? 16. And I have to remind us this, that for you to check whether what you have done is right, the sum of all the probabilities must give us 1. So if you say this plus this plus this plus this plus this, it is expected to give you 1. And with that, you can say that you have done the right thing. So by implication, using this formula, somebody can give you a question that borders on any number of coins or any number of what of trials, and then begin to ask you on the probability of getting a certain outcome and the rest of them. So the only thing is for you to be making use of this. So if you are told now that 4 fake coins are tossed up together, that you should obtain the range space, this is the range space, then you should obtain a probability distribution. You do all of these things now, and from this, you will be able to prepare your probability distribution. Thank you very much for your audience so far, and always remember to subscribe to our YouTube channel, keep following our classes, and I assure you that you become a lot a better person in the understanding of probability, or in the understanding of statistics and mathematics in general. See you in our next class.